STRinGS, Selective Text Refinement in Gaussian Splatting. Existing Gaussian splatting approaches perform coarse-to-fine optimization, which results in high-frequency details like text to be poorly reconstructed. As text is a critical element of real-world scenes, preserving text readability is important. We propose STRinGS, the first framework for explicit text refinement in 3D Gaussian splatting. By treating text and non-text regions separately, STRinGS enables reconstruction of accurate and readable text. STRinGS pipeline begins with a set of input images, which are passed to CallMap to obtain a sparse point cloud. We also obtain binary text masks using HiSam as a text segmentation model. A text region's visual footprint includes not only the strokes themselves, but also its immediate background, which is often captured by nearby Gaussians. Hence, we apply morphological dilation to the tight HiSam masks. To enable text-aware reconstruction, we identify the 3D points that correspond to textual regions in the scene. To do this, we propose a novel text segmentation in 3D algorithm. We project each 3D point into all images where it is visible and check whether its 2D projection falls inside the corresponding text mask. On the basis of this visibility count, we classify each point as text or non-text. Now we begin with the two-phase optimization where we treat the text and non-text regions separately. In phase 1, we selectively refine the text Gaussians. Since CallMap outputs a sparse point cloud, high-frequency structures like text are underrepresented. Hence, we densify the text Gaussians at the start of phase 1. The densification factor is inversely proportional to the visibility count of each Gaussian. Now that we have sufficient Gaussians to represent the text, we log their position parameters while allowing other parameters such as opacity, scales, and spherical harmonics to be updated. This prevents the Gaussians from drifting away from the textual regions. Since phase 1 deals with only the text Gaussians, we mask the loss function to ensure that the optimization focuses only on the text regions. The output of phase 1 is a splat of the textual regions. We merge this with the initialization of the non-text points and begin phase 2. In phase 2, we perform full scene optimization. Since text regions are already well reconstructed, whereas the background is randomly initialized, we optimize them with different positional learning rate schedules. For text, we use an increasing LR factor as a sigmoid function, which results in conservative early updates that preserve existing structure while providing flexibility later. For non-text regions, we scale down the learning rate to ensure compatibility with the text Gaussians. The output of the pipeline is a text-refined Gaussian splat. Here is the overview of the entire method.
Existing 3D scene datasets lack semantically meaningful text, making them unsuitable for evaluating methods that target text-specific refinement. To address this, we introduce STRinGS 360, a curated dataset of 5 indoor scenes designed to benchmark text readability in 3D Gaussian splatting. These scenes contain text in flat, cylindrical, and spherical configurations that offer a diverse and realistic benchmark. Existing reconstruction metrics like PSNR, SSIM, and LPIPs assess global appearance. Scenes contain text that occupies a small fraction of the images but has high semantic importance. Character-level distortions or misalignments impair text legibility but barely affect PSNR or SSIM scores. To address this limitation, we introduce an OCR-based evaluation score that measures the quality of reconstructed text. STRinGS outperforms all baselines across all datasets at 7K and 30K iterations, both in terms of text readability measured by OCR character error rate and faster training time. Quantitatively, STRinGS results in a 63.6% relative improvement over 3DGS at just 7K iterations. Coarse-to-fine optimization of 3DGS produces legible text only at later stages of training. Our method achieves readable text as early as 3K iterations. These are qualitative results comparing STRinGS with 3DGS at 7K iterations. At 30K iterations, our method consistently preserves text clarity even in visually challenging regions where other methods miss fine textual details. Here are visual comparisons of our method against baselines at 7K iterations on a scene from our dataset. By decoupling the optimization of text and non-text Gaussians, STRinGS outperforms others, producing sharper and more readable text.